Dear students, I welcome you in the lecture series of Digital Fundamental Digital Electronics. Today we will discuss the simplification of Boolean function using Carnot map method. As in previous lecture we see that how we can simplify the Boolean function with the help of a graphical method which is known as a Carnot map. 2 and 3 variable we have already discussed. Today we will discuss the 4 variable K-map. As the number of variable is increased, the tabular method or graphical method, it's require more cell. So this is the example, like suppose a 4 variable w, x, y, z, 4 variables are there, 4 binary variable, which is as shown in this figure, are listed 16 different combinations. All are 0, 0, 0, 0, 1. So first two digit is represent the value of w and x. Last two digit is represent the value of y and z. So here all 16 combinations are shown. The map all 16 minterms and the square is assigned to each. Mapping redrawn to show the relation of 4 variable. Okay, these all 16 minterms are there. M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, 13, 14, 15. As I saw you in form of the moving arrow, how the minterms can be written. Normally remember that thing, this 0, 0, 0, 1, 1, 1, 1 and 1, 0. It is a gray code method is that. Similarly, the each column also sequence is 0, 0, 0, 1, then 1, 1 and 1, 0. So this is also gray code method. Last two rows represent the variable x, so remaining all are x dash. Middle two row is represented by w, so that means upper and below. This upper and below row is known as a w dash. In column, the middle two column is represented by z, so left column and rightmost column is represented by z dash. The last two column is represented by the variable y, so first two column is represented as a y dash. So when we substitute, each cell is represented by minterms and it is in literals in form of w, x, y, z as the variables are used. So reflected code is that. Why? Because it's only one digit change value between the two adjacent row or column. See here, compare with the two adjacent, here all are 0, 0, 0, 1, 0, 0, 1, 1. So only one variable is different. If you compare any cell with the adjacent, upper, below, left and right side, only one variable is changed here. Suppose we compare this one, middle one. So if I beat the second last bit, it is towards the left hand side. If I change the upper last, so the next left hand side. If I replace 1 by 0, upper one is that all 0, 1. And if I MSB my will become 0 to 1, it will become down 1. So each adjacent cell is only one bit differ from the other. The minterms corresponding to each square can be obtained from the concatenation of the row number with the column number. Suppose the example here, the third row 1, 1 and the second column 0, 1 here. So it will become 1, 1, 0, 1. See here. If the column row number 1, 1, the third row, and the second column 0, 1. So this cell is represented by 1, 1, 0, 1. This one. So it's a concatenations of the row number with the column number. When concatenated, give the binary number 1, 1, 0, 1. The binary equivalent to the decimal 13. This one. It is 13. Okay. So that means the minterms for particular the square third row and second column represented by the minterms M13. The map minimization of the 4 variable Boolean function is similar to the method used in minimization of 3 variable in previous case. The adjacent squares are defined to be square next to each other. Means the map is considered to lie on a surface with the top and bottom edges as well as the right and left edges. Right and left edges, top and bottom edges, touching each other to form a adjacent square. I can make the neighbor cell adjacent cell pair. Like I suppose the example is that M0 and M2. This also M0 and M2 can be make a pair because here 0000 and the last is 0010. The second last bit is differ, so we can make the adjacent pair for this thing. In 4 variable K-map, one square is represented by one minterms. Each square is represented. So total 16 minterms are there. And each minterms gives the 4 literals W, X, Y, Z in form of W, X, Y, Z each square. But if two adjacent square M0, M1 or M5, M7 or M7, M15 means upper, lower, right and left, any two adjacent cell represent the 3 literals, one literal will become down. Instead of WXYZ, any one literal will be depends on the combination. One literal will become removed, so it will become 3 literals function or a representation of the variable. After 2 raised to 2, 4 adjacent square, the bunch of 4 adjacent square give the 2 literal function. And then 2 raised to 3, 8 adjacent square give the 1 literals. We will discuss one by one later on. And if all 16s are 0, so function is 0. All 16s are 1, so function will become 1. So no other combination of square can be simplify the function. This is only one method. We have to make the pair of adjacent square. If two square match and make a pair, it will become 3 literals. 4 squares match, it represent 2 literals. 8 squares represent 1 literals and 16 square represent 1. So we have to start from this one. If all 16s are 1, the function itself 1. If we have a 8 adjacent square function, try to maximize all minterms are covered first by 8. Then if it is not possible, go for 4. If 4 is not possible, still minterms are left, then go for 2. Again, if it is anywhere missing, so we have to go lastly 1 square represent to simplify it. Let's take one example. How the two adjacent square represent the 3 literals. So how many different combinations are possible? Suppose here in this picture, so red is shows that W0, X0, Y0 and Z0. Here 0001. So means a function only Z value is differ. So this two cell, the common thing between these two cell is the value of W is 0, so W dash, X is 0, so X dash, Y is 0, so Y dash. Like is this one, the second red circle, 1, 1. Here W is 1, so W, X is 1, so X, but Y is 0, in the both the cells it will become Y dash. Two adjacent cell give the 3 literal functions, like as the first red circle is W dash, X dash, Y dash. This below red circle is WXY. See the yellow one, first one. Here the common thing is that W and X is 0, 1. So W dash X. And Y is 1 in both the case. So Y, while Z is vary, so 3 literals W dash XY. Similarly, in this below yellow circle, WX dash Y, WX is represented by 1, 0, so WX dash. If it is 1, it is represented by W. If it is here X is 0, so it is represented by X dash. And Y is also 1, so we say that Y. Like as the another possibility is WXY is WXY total 8 combinations are there. So 1, 2, 3, 4 remaining are W dash X dash Y 0, 1, 0, 1, 0, 0 W X dash Y. 001 W dash X dash Y, this yellow circle, 1 1, so WX and Y is also 1, so YWXY. So 2 raised to 3, 8 combinations are possible in form of WXY. 4 is here shown, 1, 2, 3, 4, 5, 6, 7, 8. So in this way total 24 possibility of the three literal function by helping the two adjacent square in four variable. How the remember remaining like is here x is removed, w dash y dash z dash. See how w is 0 0, but x is vary. So x will become removed, yz is 0 0. So 0 0 0 w dash y dash z dash, and this will become 0. So w dash yz is 1 1. So we take w dash yz function is there. See below two circle. Here w is 1. So w y is 0 and z is 1. So y dash z. This circle yellow circle w is 1, so w y is also 1 y, but z is 0. It is between common between these two. It will become w dash. Here remaining all four combinations also in form of w y z. See w x z function. So here w x z function, these corners are compared with these two. Okay, so what happened? 1 0 is common, so w x dash w and x, while z is 0 in both the function, so it is z dash. While in above uppercase, this one 0 1, so w dash x is common between the second row, first and last column. While the value of z is 0 in the both the case, so w dash x z dash. Z is 1 in second column and third column. So another possibility is this circle, upper first row, middle two cell circle. So the value is 0 0 and z is 1. So w dash x dash z. Here is w x z because w x and z all are 1. The another four combinations are first row, outer cell, first and last, third row, first and last cell, and remaining two circle in second row and fourth row. So in these 8 combinations are possible, which we here discuss. This will become 0 1 w dash x and z is 1, so z. Here 1 0, so w x dash, w is 1, x is 0, so x dash, and z is 1, so z dash. These two w dash x dash z dash, and the third row represented by w x z dash. Now let's see the how the four adjacent square can be possible. So see here, the first, if all are 1, so it is a adjacent, four adjacent squares are make a one bunch. And here in 4, the common thing is that w is 0 and x is 0. Common thing is that. So it will become w dash x dash function. Third row represent again w and x is common 1 1, so it will become wx. If the second row all ones are there, so bunch of these will become 0 1 w dash x, and the last row is represented by w x dash. So 4 combination of wx is possible. Here the column wise. Suppose in first column all are 1, so it represented by y is 0 and z is 0, so y dash z dash. In last column y is 1 and z is 0. So the 4 square match and make a 2 literal function y z dash. Second row is represented by y z dash, and the third row is represented by 1 1, so y z. So 4 combinations are possibility y z. Now for x z x y, here which one? So the x is 0 in both the case, x is the second last 0, here again 0, and y is 0 0, so it will become x dash y dash. Most of the students are making mistake here. They are not understanding that the bunch of 4 minterms are possible in upper and last row. Similarly, the other possibility is this middle one. So this is xy because the second row is x and last two columns are y. So it's a bunch of this function and above one. WZ dash functions here. The upper two row and first column and last column match. The value of w is 0 and z is 0. So w dash z dash. Here it is a merging of this is w1 and middle two column is z is 1. So w z. This represented by W dash Z, and these two cell with this last two cell will become W Z dash. Four combinations of WZ function. Now let's see other possibility WY. This four cell make a group of W is 0, Y is 0. 0, 0, 0, 0. Common is for four cell is represented by W dash Y dash. Last four cell, fourth quarter, W is 1 and Y is 1. So WY. This will become W dash Y and this will become WY dash. Outer four, many times we found that the students are making mistake that if only corner ones are there, so the corner also make a one bunch, and in corner see 0 0 0 0 0 0 1 0 1 0 0 0 and 1 0 1 0. So in four corner the value of x is 0. See, x is 0 here, also here, and z is also 0, last row value. So that means all four corner match and make a one group of x dash z dash, and it's complement the middle four. Middle four quadrants, it represent the value of x is 1 1 1, and here z is also 1, so xz. Similarly, these two match with the lower four two, it will become x dash z, and here these two are matched with this one. The value of x is 1 and z is 0. So x dash x z dash. Okay. So these four are combinations. Now let's see 8 adjacent cell. Only give the one literal. Like I see here, the last two column is represented by y. So this will become y dash. All 8 are make a bunch of y dash. And if here all ones are there, so it will become y. Below row, two row represented by w, upper two row represented by w dash. Middle two columns are represented by z. First and last column, hence first and fourth column represent as a z dash. And middle two row is represented by x. So first and last row is represented by x dash. So there is a different. 8 adjacent square represent the single literal terms in 4 variable k-map. 16 min terms are there. Let's see how this thing is helpful to solve and simplify function. Suppose here the function is given 4 variable x, w, x, y, z. The minterm is listed in the sum marked by ones in the map. Let's see. Here all minterms are there. So what we'll do, first we'll put the ones on. M0, M1, M2, M4, 5, 6, then 8, 8 is here, 8, 9, 12 is there, so 12 is represented in the third row, first column, 13, third row, second column, 14 is a third row, fourth column. So total 8 plus 3, 11 minterms are there. Now first, all 6s are not possible. Let's see, 8's ones are there, yes. The first two columns make the bunch of 8 literals. And what is the common thing is that in first column and second column, the value of y is 0. So this combination is known as a y dash. Now 3 is there. That is, if we are 1, we can make a group of 4, but it is missing. So can we make the group of 4? Yes. Which 4? First row, second row, first column, last column. So here 4 adjacent cell give the 2 literals function. The value of w is 0 in this all 4 cell, and the value of z is 0 in the all 4 cell. So it will become indicated as a w dash z dash. The value of w is 0 and z is 0 in each 4 yellow combinations. Now 1 is missing. We have to take care that any one minterms cannot be missed, as well as minimum literal function is required. So circuit size will become reduced and we can reduce the consumption power. Now, if one possibility is that I can make a bunch of these two adjacent cells, but can I make the bunch of four? So it will become reduce the one literal and it can reduce the circuit size. Yes. How? These two with the first two. The value of x is 1 in the second and third row, and the value of z is 0 here and here. Okay, so this bunch of 4 is possibility. For bunch of 4 adjacent cell is give the function x z dash. So my final result will become y dash red 1, x z dash yellow one, the blue one, and w dash z dash is yellow one combination. I hope is it making sense to find out the simplified function if it is listed the min terms. Sum of min terms is given to us. Suppose the function is given. We have to simplify it to reduce the circuit size. What we'll do first, we'll make the k-map of 4 variable. A, B represented by row, C, D is represented by column. Okay, A dash B dash C dash, or B dash C D dash, or A dash B C D dash, or A B dash C. A dash first two row, B dash this row only, which give A dash B dash 0 0 0 0. Now C dash is C 0, so this and this one. So it represents the first two, A dash B dash C dash, where A, B and C all three are 0, which is possible only for these two cell. B dash second function, B dash means B equal to 0, so it is possible only first row and last row. B is 0, C is 1, where C is 1, these two columns, so these two and these two is possible. D dash D is 0, so only these two. Fourth column, first row and last row give the B dash C dash D function. A dash B C D dash, all literals are there, so that means one cell is that A dash, so 0 this for two row, B 1, so 0 1 this row, C, so only two minterms are there, and D dash, so that means these minterms are there. A dash B C dash. A B dash C. Similarly, A B dash C is the 1 0 and 0. So this will become there. So finally we got 1 2 3 4 5 6 7. 7 midterms are there. This just redraw this thing. So we can now make a simplified function. First, is it possible 8? No. Is it possible bunch of 4 adjacent cell? Yes, this one. All corners. Or corners are there, the corners is indicated by B dash D dash. The value of B is 0 and D is 0 in all corners, so it will become take B dash D dash. Now how many minterms are left? 1 2 and 3. Now let's see this one and this one. If I make the bunch of these 4, all 2 minterms will be covered, and it is indicated by B dash C dash. Now 1 is missing. Can I make the bunch of 4? No. If here 1 is that, then and then the possibility is that. So now it is not possible. Can I make a bunch of 2 adjacent cell? Yes. Upper one. Always compare upper, lower, right and left. So here the possible is upper one is there, and it is A dash C D, because A value is 0, C is 1 and D is 0. So A dash C and D dash. So find all are covered. B dash C dash, or B dash D dash, or A dash C D dash. So here the function is 4, it converted into 3 terms, and here one literals will be reduced. So circuit side is reduced more than half, and it simplified form of the given function. Suppose here the function is, we have to find out in product of sum term. Remember the POS, and we have to use the k-map. Please note down that thing. It is possible the sum of product term is a complement of the product of sum. Pi function is given. So we use this is our K-map. The smaller mean terms is the sum of product term. The function is given pi, so product of sum term. So what we'll do, we will put 0 in this function because it is a complement to each other. So M0, 1 is here, so M1, POS max term is 2, so here we put 2, 3, so this one is 3, fourth PO max term, so this will become 4th, 10th is here, and 11th is here. 4, 5, 6, 7. 7 max term is there. Whatever our min terms, we have to complement. First, we identify the common thing, make a bunch of 4, 2 in such a way that then whatever the min terms for particular or whatever the literals, we have to complement it. So we can got the result is in POS from product of sum. Let's see. The first row is common. First row A is equal to 0, B is equal to 0. So as per our Minterms definition, it will become A dash B dash. But we have to find out the result. Answer is in POS form, product of sum. So what we'll do, we take the complement. So A dash and then B dash whole dash. As per the De Morgan's theorem, it will become A dash dash plus B dash dash. So it will become A plus B. Remember why we are taking, because the product term is given, pi is given. So we put 0 and all 0 combination give the result in POS form. Now these two can be merged with this upper two and make a group of 4 adjacent cells. And common thing is that B is equal to 0, 0 here, and C is equal to 1. So it will become B dash C, but it is in form of POS. So we take the complement B dash C whole dash. As per the De Morgan's theorem, it will become B dash dash plus C dash. So it will become B dash dash B plus C dash. Now one max term is missing, so we take this one with a bunch of these two. And common thing is that A is 0, C is 0, D is 0. So it will become A dash, C dash, D dash. POS form, so we take complement. So A dash dash A plus C dash dash C plus D dash dash D. So A plus C plus D. And combination of these three functions is result is A plus B ended with B plus C dash ended with A plus C plus D. So this is known as a product of sum, POS. Is it making sense? I hope you can understood that things. Let's take one another example. Now here we have to find out the product of sum and sum of product. So product of sum, but given is in min term sigma. So what we'll do first, we'll draw out that things. Min term, so we have to put the 1 here. 0 M0, 1 M1 here, 2, so this min term, 5, 8, 9 and 10. Why we put here 1? Because the sigma is given. Sigma is the sum of product, SOP. Min terms are there, not max term. If max term is given, we have to put the 0. So first we will find out the sum of product. So consider these min terms, outer all 4. So it will become B dash D dash. Now these two match with the lower two. It gives B dash C dash. Now which one is missing? Yes, M15 is missing. And M15 can make a bunch of this with adjacent cell. And this will become A dash, C dash, D dash. A dash 0, C dash and D. So the function is B dash D dash plus B dash C dash plus A C dash D. Here D dash not is, it is a D, consider it. Now what we'll do, we have to find out the sum of product term. This one. Now the next topic is that we have to take the product of sum. Here it is misprinted. So consider is a product of sum term. Sum using K-map. So sum and using is merged. So it is a typing mistake is there. Please neglect it and ignore it. Now we have to put 0 in the remaining cell. So M3 is missing, so I put 0 here. In second row, M4, M6, and M7. M4, M6, M7. In the 8, 9 is there, 10, 11 is there missing. So 11, and third row whole missing. So 0, 12, 13, 14, and 15. We got 4, 5, 6, 7, 8, 9. 9 max terms are there. So first we make the bunch of this 4 column, and common is C is equal to 1, D is equal to 1. So C D whole dash, it will become C dash plus D dash. C D 1 1. So we have to take the complement C dash or D dash. Third row represent A equal to 1, B equal to 1, AB equal to 1. So it will represent A dash plus B dash. Now these two are possible. And where BD is 0, 1 and 0, B dash plus D. So three functions are there, all base terms are covered. So finally we got a function in product of sum is A dash plus B, second term is C dash plus D dash, and third term is B dash plus D. So in this way, without the knowledge of any theorems or postulate, with the help of graphically KMF method, we can minimize the function in any form. It may be a sum of product or product of sum. So in this way, we can use the simplification of any digital circuit elements with the help of 4-variable K-map. So I hope whatever the different steps and examples today we discussed, it will be helpful to you for the any digital system design. Have a good day.